welcome to DevOps at the Speed of Architecture. I'm Erick Minick, and I'm really excited to talk about the interplay between architecture, DevOps, and how quickly you actually go. I've spent the last 15 or 20 years in the continuous integration, continuous delivery space, worked on a bunch of tools there. And what struck me over the last few years was how much the type of continuous delivery you do is tied into the sorts of architectures that you're using. Things are just a little different in cloud native than they are in distributed systems and good old SOA and a little bit in mainframe. And where I've seen so many people struggle is when they're trying to apply techniques that come from a different world to their own space, it just doesn't fit right. So we're going to talk about how these things intersect and how to apply things that you're learning to your context better, right? So as I was thinking about DevOps and architecture and preparing for this talk, I was Googling around. It's like, where do you start? Well, the hotness right now really is in the cloud native domain. And the App Dynamics team has these lovely pages. They're talking about all sorts of best practices and things. And on their page about cloud native architecture, they write that cloud native architecture is a design methodology, I like that term, that utilizes cloud services, pretty obvious so far, to allow dynamic and agile application development techniques. Why are we doing cloud native? Because we want to go faster. We want to realize the benefits of agile. That's a really striking statement for them to just kind of slide in there at the end of the sentence. Oh, we're doing this to make agile work, right? I thought that was interesting, and it points to this sort of intersection. I was then thinking, well, what would be like the most different way of architecting than cloud native? And it's like, all right, maybe mainframe. Mainframe's good. And as I was thinking about that, searched it up, as my kids say, and you get this like everybody talking about mainframe DevOps thing. All of the vendors in the mainframe area, whether it's your IBMs, your Broadcoms, Micro Focus, BMC types, they're all talking mainframe DevOps. And is that going to be the same as the sort of cloud native work that you're doing? Probably not, right? But it is searching for supporting Agile. And honestly, a lot more of it's similar than you might expect, right? If you're like, well, can I set up a Jenkins pipeline to build and deploy and kick off tests around my mainframe code? Yes, absolutely. But are all the same approaches going to be applicable? No. So know your world. Know that DevOps is applicable just about everywhere. But let's make sure that as we're thinking about capabilities, we do so with the architecture that we're actually in, properly in mind. So if it's applicable everywhere, what are the key tenets? And I went back to one of my favorite books about DevOps, Accelerate, by Forsgren, Humble, Gene Kim. I think Gene is probably talking at this conference as well. And right up at the top of their section on architecture, they have this beautiful little statement that high performance is possible with all kinds of systems, provided that they're loosely coupled, right? You can be successful in a DevOps fashion, right? As measured by things like how often are you delivering? What sort of incidents do you have when you do delivery? How successful is the team? You can get that high performance, whether you're cloud native, distributed, mainframe, doing IoT applications, whatever your fundamental architectures are, you can be successful. The key is to be loosely coupled. So that's how we're going to think about things, is not as much about the infrastructure side. Are you running on a big box in your data center, or are you running the cloud? And that's important, and we'll touch on that. But the coupling is going to be the most important level of determination around whether you can be successful with the most advanced DevOps techniques. And the way I would think about this is, if I'm writing a decoupled microservice, right? And I think about what it takes to build, deploy, and test that thing, get it out the door, it's relatively simple, right? I'm putting out some sort of a contract that says, here's the API I'm fulfilling. And I can then test that contract of my one service. So I build my service, I deploy my service into a test environment, I then test that API. API tests are pretty quick. If that passes, then I know I'm fulfilling my contract as I should be. And that can be then released into production fairly independently, knowing that I'm unlikely to break everybody else. As long as they're expecting me to behave to my contract and I follow my contract, we're all good, right? That's simple. And the same thing is true if I'm writing some mainframe app or something, right? Or a service running behind some, broker. If there's an API I'm supposed to fulfill and we test that API, I can then go out independently. Now, if instead you have what I think is the most common architecture in the enterprise right now, which is the distributed monolith, where you have a whole bunch of runtime services and databases and stuff. And when I change one, I get really worried that I'm going to break somebody else, right? We don't all have firm contracts that we stick to and people expect. We have code that we call from each other. If we're a distributed monolith, well, when I change my thing, what I'm worried about is whether other people break. And so I need to deploy myself into an integration environment, get tested, and see if I'm still working and whether I've broken anybody else. And that requires coordination around testing, shared environments. My changes likely are being tested against someone else's changes. When we're deploying to production, we're less likely to be deploying just my service. We're deploying lots of things together. The level of coordination goes up, the coordination around testing goes up, security testing gets more complicated. Everything is slower and worse. So coupling is the architectural construct that we really care about. Running on a cloud is nice from this perspective, and I think has the most impact as we look at resiliency, right? If my thing falls over, can I bring it back really quickly? Can I scale up and scale down nicely? Cloud's going to have really important impacts there. But from a how quickly do I deploy? How quickly do I test? How quickly can I release? Loose coupling is where it's at, right? And this is a principle that I think kind of understood in application architecture for 30 years, but it's so important these days as we think about DevOps. Now, I will admit that in this spot, the ellipses are doing some work. What I took out in these ellipses is that it's not just the teams that need to be loosely coupled, or it's not just the systems, it's also the teams, right? And this makes a lot of sense to anyone who's familiar with Conway's Law, right? So Melvin Conway laid this down back in the 60s, saying that any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. Yikes. This was simplified nicely by Erick Raymond, who said, yeah, if you have 4 development teams and you ask them to write a compiler, you're going to get a 4-pass compiler. The architectures you end up being a mirror of your organization. and how the different parts of your architecture interact mirrors how the people interact, how the teams interact. So that is pretty profound, right? You're unlikely to get a microservice architecture if you just have a team that is 100 developers with some architects and testers rolled in. Right? You have that many people involved, you're going to get a big ball of interrelated stuff because your organization is a big ball. If instead your organization is split into teams of 4 to 8, and those teams are kept somewhat apart from one another, then you are much more likely to get smaller services that are somewhat apart from one another. You just have to make sure the communication between those teams is pretty good, and often around agreements and understanding team to team rather than at a really low level where you're likely to circumvent APIs and stuff. So that leads to a concept that I just want to touch on briefly because it's got the coolest name, the inverse Conway maneuver, which sounds super fancy. But basically it means that if you want to change your architecture, change the org chart, right? If your org chart is not conducive to the architecture you want, as understood by Conway's Law, change the org chart as you're trying to change the architecture. I think if you look at some of what happened in Amazon as they moved to microservices, it's around the same time they started talking about 2 pizza teams, right? Change the org chart, have that 2 pizza team if you want 2 pizzas worth of services. Cool. All right. So with that said, I then want to look a little bit more detailed at the interaction here. This visualization is inspired by something that I found in the Lean Enterprise book by Jez Humble and a couple other smart folks. It was pulled in there, credited to Paul Hammett. I've gone and changed it a bit, but Paul deserves a ton of credit for this sort of conceptual thing. And it's like a favorite graphic I've seen in kind of DevOps and in Lean books. So it's a little overwhelming, and so I'm going to step through this piece by piece to look at this interplay. So what we've done as a framing mechanism is we've looked at your release cadence, and we're going to map that back to different DevOps practices. The idea being that if you have something like feature flags, right, that could be extremely powerful if you're releasing all the time, many times a day or daily. And you're going to push a release out maybe before the functionality should be live, and you're going to toggle things on and off. Like, that makes sense in that world. If you're releasing quarterly, feature flags are going to be a lot less valuable to you, right? And so when you read that blog entry that says feature flags are how we manage to be successful in our DevOps something or other and our digital transformation, you don't want to rush to feature flags before you bring your release cadence faster than quarterly, right? Get it at least to like weekly or something. So we're going to map the practices to these speeds. And I'll observe that this is roughly a logarithmic type of visualization. Many times a day is 10 or 20 times faster than daily. The same way that weekly is 4 or 5 times faster than monthly, right? So it's logarithmic as we work our way down this. Now, I want to start on the left-hand side of this. So I've kind of grayed out the right. And look at how things work in that quarterly, monthly, kind of getting into weekly. And I want to do that because there are a lot of these practices, and we put these ranges of where they're effective. They stop being effective somewhere around the twice monthly release, every 2 week release kind of cadence. Um, this moving from a monthly cadence to a weekly cadence, that's bigger than moving from quarterly to monthly, or I'd argue from weekly to daily in most cases. A lot of practices break in this sort of cycle. So if you found that you were able to go from quarterly to monthly really well, and then started struggling as you went to every 2 weeks and don't really know how you're going to get to weekly, that's pretty normal because that's where things tend to break. So we'll say that. I want to look at it as from an architectural point of view, which is kind of our theme here for today. You can have significant coupling. You can have a distributed monolith and be okay down to maybe a weekly release, certainly to a bi-weekly release. That overhead of I test a bunch of things together and I release a bunch of things together can be accommodated pretty well, right? In my recent role, I was doing release automation tools before I came over to CodeLogic to focus on architecture. And those tools are all about how do I take a bunch of related stuff and move it through a pipeline together. And those sorts of tools will get you from a monthly release to a biweekly or weekly release with coupling. You can do that. A lot of what you're going to do in a biweekly release can look a lot like what you're doing in a quarterly release cycle, just better, right? More automation, faster sprints, tighter this and that. You can get away with it. From a coding sort of perspective, how you're going to do your day-to-day development, your branching structure, things like that, you can have long-lived branches, right? You can say, this is our release branch for the next release, up to about a monthly release. And you might have release branches that you keep around, kind of forking off trunk down to a biweekly or weekly release. You will see that that just doesn't make sense to have branches for releases as we get faster than a weekly release. They just don't live long enough to be worth the overhead. Similarly, from a testing point of view, you're going to need increased automation as you move from a quarterly release down towards that biweekly release. You're going to need to be mostly automated for biweekly. But that automation can be done with a blend of development and dedicated QA people. A dedicated QA team can be just fine in this sort of time frame. You have time to have meetings with QA if you're releasing once a month, twice a month, something like that. Your databases, you'll benefit, particularly as you get into biweekly or weekly releases, to automate your database deployments, just like you did your app deployments. But you might not have to do it, right? Particularly if you're not updating your databases all the time, you can still kind of get away with manual database updates up to about a biweekly release. After that, you really want to automate it. From an infrastructure point of view, monthly release, biweekly release, your environments, like as fun as it is to press a button and get a test environment, or do your automated tests by spinning up an environment, running the tests and spinning it down, that is fun and it is useful and good. And it might be an efficient way to use CPU resources and compute and all that. I love it. You can also just have some VMs that are your test environment. And when you do builds, chuck them out there, run some automated tests. Maybe you're running some manual tests. It's okay. The kind of traditional VM environment, where if you needed a new environment, you create a ticket in ServiceNow and ask someone to please create you a new environment, and you get it in a couple of weeks. It's probably okay as long as you don't need different environments for every release. You usually don't, right? Traditional infrastructure can do okay. You don't have to have cloud. And then from a monitoring point of view, again, fairly traditional setup with an operations team that keeps an eye on when things start going sideways. That'll work. As you accelerate, you're going to have more and more changes going into production. And so the risk that you knock something over is going up. That's okay. You'll need better monitoring. Ideally, it's going to be more proactive and identify smoke, not fire. And that's just where monitoring and APM tools are these days. They're pretty good at that sort of thing. Organizationally, you don't need to change everything for a monthly release, bi-weekly release. As you accelerate, things are going to be a little bit different. So I said a lot of this forward-looking stuff about accelerating. Let's look a little bit more to the right-hand side. As you start getting past a weekly, bi-weekly release, you don't have the time for the coordination, right? This is where that decoupled microservice kind of thing is important. And strict service-oriented architecture is another way of talking about this. When we talked about service-oriented architectures 10, 15 years ago, it was the same idea in many ways as microservices. We just want to decouple things and have isolated, smallish chunks responsible for discrete activities and discrete domains. So yeah, you can still have like that enterprise service bus. That's fine. If you're actually decoupled, most of us had massively coupled distributed monoliths with an ESP in the middle, and so we're not trying to get away from that. But we want that sort of decoupling. That decoupling needs to take into account the database tier as well. There's a lot of good content around how you would align the data to those individual services and put in some event messaging systems. All of that comes in. And this can be a profound re-architecture to move from a distributed monolith to an actually decoupled service, and a decoupled service that can accommodate data change as well. It's not a joke, right? It's a big lift. And I think a key consideration in deciding whether or not to make that lift is, do I need these sorts of capabilities, or are they nice to have? If we can get to pretty good uptime, adequate scalability, and a bi-weekly release cycle, is that good enough for the business? Or do we need to make that bigger investment to transform to something else going forward? Now, as we go forward, I think if we make these sorts of changes, a lot of the other things that we do also change, but in many ways are simpler, right? And I think our branching strategy and kind of our coding methods are a good example of this, right? We're going to move from managing lots of different branches and dealing with merge flows and all of that to something that looks a lot more like trunk-based development that can have a Git flow element to it. But we should not have those pull requests and merge requests sitting out by themselves for a long time. They need to be pulled in relatively quickly. From a testing point of view, we need really good test automation at this point. You're not doing a lot of manual testing. It probably means your testers and your developers are one team all working together. Your deployments are now a lot simpler. You're not doing things fancy because you're coordinating how lots of things go out together. You're going to reserve your fanciness for like a progressive delivery style of change. How do I deploy something and test it in production with customer usage rather than just rely on those functional tests or automated unit tests that we ran earlier? So those feature flags become absolutely critical. You're going to be looking for techniques where you're able to release your software or features of your software to a subset of your users, whether that's a canary or a dark launch or something like that. Similarly, databases, we talked about the architecture needs to be tidy, but also how you do your deployments of that database. You're not doing handcrafted SQL deployments or anything anymore. You've got some system in place to automate your database change, right? Maybe you're doing something with a DB Maestro or a Liquid base. Those are great. Some sort of way of automating that to make sure your database changes are as seamless as your application tier. And that'll change a little bit whether you're doing SQL or NoSQL style databases. From an infrastructure point of view, you need to be able to get the environments that you want more or less on demand. Saying that you're going to go to microservices and then be in a situation where you need to create a bunch of tickets and beg the infrastructure team for more infrastructure in order to run the next service, like that doesn't fit very well and will discourage you from having the architecture that you want. So you should have a platform, and we do see a rise out there in the industry of platform teams, of making sure platforms are available to the application teams. And so that might be a Kubernetes-based thing, it might be serverless, because we're seeing less Cloud Foundry. But whatever that platform is, you need a simple way of getting your infrastructure that you need to match your new capabilities. And finally, on your monitoring side of things, you're probably moving into a much more proactive mode than you were before. And the relationship between that operations team that is watching the app to see if it falls over and the development team is much tighter. You might be in a you build it, you run it kind of mode where the development team is the operations team or has the operations team within it. You might have something more like a site reliability engineer, which kind of spans the traditional and the more modern approaches and brings dedicated expertise in while still putting responsibility back to development. There's some flexibility there, but the old ways of working are just not going to cut it. So that's a summary. I could very happily spend an hour and a half on this slide, but hopefully this sort of thing makes sense. You want to be able to draw a vertical line wherever your release cadence or desired release cadence is. Look at the practices there, compare that to the actual practices you have, and go, yeah, that's about what we're doing. We are in the right realm. Where you get a mess is when you start doing things that make a ton of sense way off on the right, when your release cadence and some of the other things you're doing are way off on the left, right? That gets you into trouble really quickly. And again, I would point out that somewhere between monthly and weekly, a ton of things change. And so if you're looking to make that leap, expect that you need to change everything. How you're doing deployments and tests and managing your databases and potentially your infrastructure, and your architecture better be as decoupled as that senior architect said it was up on the whiteboard. So that's the challenge I've got for you. A couple of things to take away out of this talk. Your architecture constrains your release cadence. If you're not decoupled, don't try to go faster than once a week. Re-architecting, in turn, is really expensive. And if you're going to make the leap, it better be because you've got either a resiliency issue or you need to go faster than once a week on your releases, right? Don't re-architect just for fun. Now, if you do have to rewrite an app, architect it as best you can. Finally, align that organization. Keep Conway's Law in mind. Make sure that organization, the practices, and the architecture are all in line. And with that, we'll wrap up, and I think we'll have some time for Q&A. I'll be hanging out here in the chat. Love to talk to you more about that. Thank you for joining me today. And yeah, it's been fun coming to you from CodeLogic, the architecture company. Cheers.